Okay, so Assalamualaikum and good day everyone. So today we are going to continue with the next topic, which is topic 2, integration. So in other words, it's a pembezaan. For those who took at maths, you know this is the one of the topic in your SPM paper, right? Okay, so integration. So we have several subtopic. The first lecture we are going to focus on the first subtopic, which is integration of function. So the learning outcome for this lecture, at the end of the lesson, students should be able to relate the integration and differentiation. Okay, so you know how to relate integration and differentiation, and then use the basic rule of integration, the same as differentiation. So you need to use the basic rule to solve all the type of question. And then determine the integration of e to the power of x, e to the power of ax plus b, 1 over x, 1 over ax plus b. So this is question related to exponent and reciprocal. And lastly, to determine the integral of the form, so we have these three spatial form, which is the first one is f prime x over fx. The second one is f prime x multiplied with e to the power of fx. And the last one is f prime x multiplied with f of x all to the power of n. Okay, so let's start. So what is the content of this lecture? Okay, integration is the reverse of differentiation and is also known as antiderivative. Okay, so if it's an reverse, a reverse of differentiation means that if we do differentiation to a function, then there will be another function. And then if we reverse it, we reverse the other function with integration, we will get the original function fx. So the process of finding antiderivative is called integration. So if, let's say we have dy dx, derivative of y respect to x, which is equal to f prime x, then the integration of f prime x, because we are reversing, we will get the original function y. Okay, which is we can write it as capital F of x plus c. So what is this c? C just can be any constant. Okay, we represent the indefinite integration by plus c. Okay, the symbol integral is called the integral sign. The term that is being integrated, which is f prime s, is integrand. So integral sign, integrand, and dx means integrate with respect to x. The same way to write to pronounce for the differentiation, respect to x, respect to y, respect to z, and so on. So since d dx over 3x squared minus x, so how do we differentiate this? Okay, we bring the power to the front, so we get 2 multiplied by 3, which is 6, multiplied by x to the power of 2 minus 1, which is equal to 1. And then this negative x will be 1. So the integration or the integral of 6x minus 1 respect to x. Why? We need to do it respect to x, respect to the variable that we want to integrate. Okay, the integration of the results here will give you the original function 3x squared minus x, but now we have to put plus c, because let's say we have plus 1 here. If we want to integrate plus 1, differentiate plus 1, we will get 0, right? So if we integrate 2, also 0. So we have this constant that we don't know what is it. So that's why we need to represent it as plus c. Okay, we can say that 3x squared minus x is an antiderivative of 6x minus 1, and c is a constant. So example, let's see some basic example. Rewrite the following antiderivative using integral notation. So for example, first one, we have the derivative of 4x respect to x equal to 4. Then in antiderivative form, we need to put integral on both sides. So if we integrate respect to x, so on the right side also we need to integrate respect to x. Okay, so what do we have here? This dx will be cancelled out, right? We will have dx here. So this dx will be cancelled out. So we have 4x is actually equal to integral of 4 dx. And then for x, we need to add up by c because we don't know if there is any constant after the 4x. So just to be safe, we put the plus c. Okay? So for question B, d dx of 3x squared is equal to 6x. Then we put integral on both sides. So what do we get? The integral of 6x respect to x is equal to 3x squared. And then plus c. Okay? Question C. The derivative of e to the power of x is equal to e to the power of x. Then the integral of e to the power of x is equal to respect to x is equal to e to the power of x plus c. So the same answer here. Okay? And D, the derivative of natural log x is equal to 1 over x. Then the integral of 1 over x respect to x is equal to natural log x plus c. Okay? Okay, so let's move on with example 2. So we have if d dx of 1 over 1 plus x squared is equal to negative 2x all over 1 plus x squared all squared. Okay, now we have this type of function. Then find the integral of negative 4x respect to x. Okay, we want to find the integral. If we can compare this answer with this integral, we can see that this negative 4x is actually multiply of 2 of negative 2x. So we can factorize out 2, which is we will get negative 2x over 1 plus x squared all squared respect to x inside the integral notation, right? So the integral of this expression here is antiderivative of 1 over 1 plus x squared. So we will have the answer as 2 multiplied by 1 over 1 plus x squared. And then we need to put plus c. So this is the final answer without doing any integration using a formula. So we just have to apply the antiderivative, the reverse of derivative, the reverse of differentiation. So that's all for example 2. So we can write down the final answer equal to 2 over 1 plus x squared plus c. Okay, so simple, right? The concept of differentiation and integration, they are reverse of each other. Okay, so to solve a problem related to integration, we need to know the basic rules of integration. Okay, the same things as differentiation, we have the basic rule. The first one is to integrate 1, which is a constant. We directly get 1x plus c. So if we get integration of 2, then we get 2x plus c. Okay, this is a constant rule. So usually we represent it as integrate of k respect to x is equal to kx plus c. And then the next one, if we have x a polynomial to power of n, then the integral of x power of n is equal to x power of n plus 1 and divide with the power n plus 1. Okay, so we adding up the power plus 1 and then we need to divide with the total power after the integration and then plus c. So this is power rule. Well, n must not equal to negative 1. Why? If we have negative 1, then it will be negative 1 plus 1, which is 0. So it's not true. Okay, so if n to the power of negative 1, then we will have 1 over x. So 1 over x has their own rules to solve. Okay, the third one is if we have an expression inside the bracket in the form of linear expression. So it should be ax plus b all to the power of n. We can't have in other form, let's say ax squared plus bx plus c. No, we cannot. It's only linear expression all to the power of n. Then the integral will be all to the power all in the bracket of ax plus b all to the power of n plus 1 and divide with n plus 1, and also the derivative or the coefficient of x inside the bracket. And then don't forget to put plus c. Okay, this is also power rule. This n also cannot be negative 1. Okay, this n also cannot be negative 1. Okay, and lastly, if we have a multiplication of k with the function of fx, then we can take out the coefficient k. So we just have to integrate the f of x. This is constant multiple rule. This fx can be anything. And lastly, the addition or summation between two functions, we can do the integration separately. Okay, so the sum and difference rule. So let's continue with the example. Find the following integral. So the first question is integration of x to the power of 4 respect to x. What we need to do, just apply the basic rule, which is the power rule. So x to the power of n plus 1, which is 5. 4 plus 1 will be 5, and then divide by that 5 and then plus with c. And the second one, integration of 1 over 2x cubed dx. And now we have 1 over, but this x can be written in the form of x to the power of negative 3. Why? Because it's n in index form. So x to the power of negative 3 is not negative 1, so we can integrate by using the power rule. So what is the results? So we have x to the power of negative 3 to power of negative 3 plus with 1. That's why we will have negative 2. And then we have also to divide with negative 2 at the bottom of x. And then plus c. So simplify the answer, we will get negative 1 over 4 of x to the power of negative 2, or we can put x to the power of 2 at the denominator and then plus with c. So just apply the rule of indices. So C. So integration of square root of x respect to x. What is square root of x? By using the rule of indices, it's actually x to the power of 1 over 2. So apply the power rule, we get x to the power of 1 over 2 plus 1. 1 over 2 plus 1, which is 1 over 2 plus 2 over 2, which is equal to 3 over 2. So x to the power of 3 over 2 divided by 3 over 2. So if we have a over b over c, then it will be a multiplied with c over b. Okay, so it will be 2 over 3 of x to the power of 3 over 2 and plus with c. And for question D, we have integration of 7y to the power of 3 over 4 respect to y. So first, this 7 is just the coefficient of the y. So we can take out it as the coefficient of the fx. And then we integrate the y to the power of 3 over 4, applying the power rule. So we have 3 over 4 plus 1 equal to 3 over 4 plus 4 over 4, which is equal to 7 over 4. That's why we have y to the power of 7 over 4 divided by 7 over 4. This 7 can be cancelled out, so we only have 4 multiplied by y to the power of 7 over 4 plus c. Okay, so the same thing as question C. This 7 over 4 divided by 7 over 4 just the same as multiply with 4 over 7. So example 4, find the following integrals. So we have a function of integration 3x6 to the power of 6 minus 2x squared plus 7x plus 5 respect to x. So integrate separately. So we can integrate this term first, this term, and last term. So for the 3x to the power of 6, it will be 3x to the power of 7 over 7. And then minus 2x to the power of 2 will be minus 2x to the power of 3 over 3. And 7x will be 7x squared over 2. And 5 will be 5x, and then plus with c. Okay, really simple. Just integrate separately each by each term. And then for question B, integrate the x plus 1 multiplied by 2 minus x. So do we have any formula with this multiplication between two factors? No, but we also know that we can expand expand. Okay, do the basic things first, basic technique that you know in mathematics. What we can do here, we can expand. So expand here, we will get x multiplied by 2 is 2x. X multiplied by x is negative x squared. 1 multiplied by 2 is 2, and 1 multiplied by negative x is negative x. And then we can integrate separately. So integrate 2x, we get 2x squared over 2, which is equal to x. Okay, sorry. We can simplify by subtracting this x from 2x. So we get x minus x squared plus 2. Now we do the integration. So integrate x, we get x squared over 2. Integrate negative x squared, we get negative x cubed over 3. And then integrate 2, we get 2x plus c. Okay, for question C. Do we have a quotient rule for integration? We don't know anything about quotient rule. Quotient rule is only for differentiation. So how to do this type of question? So here we actually have the love form, right? So means that we can separate the terms here. Okay, so this is only the common denominator, so we can separate it into x power of 5 over x power of 4, and then 2x squared over x power of 4, and then 1 over x power of 4. So we separate each of these terms. What we will get is actually integrate of x only, because x power of 5 over x power of 4. Right, apply the rule of indices. So x power of 5 minus 4, which is equal to x power of 1. And then 2x squared over x power of 4, we get 2x over x, 2 over x squared. Right, so x squared over x power of 4 is equal to x2 minus 4, which is equal to x negative 2, which is equal to 1 over x squared. Okay, this is all rule of indices. So nothing new. Okay, the only thing new here is the integration. And then the last one is negative 1 over x power of 4 respect to x. So now, how to integrate? For the second and third term, we need to bring x to the denominator, to the numerator part lah. So basic rule of indices. So it will be x power of negative 2 and x power of negative 4. So integrate each of the term. So it will be x plus 2x power of negative 2 plus, minus x power of negative 4 respect to x. So x will be x squared over 2. X power of negative 2 will be x power of negative 1, right? Adding up by 1. So negative 1 over negative 1, that's why we have negative. So 2 over x, okay? This is x squared over 2. This is 2x power of negative 1 over negative 1. And then this one is negative x power of negative 3 over negative 3. So negative will be positive. Then plus c. So that's why we have an answer of x squared minus 2 over x plus 1 over 3x cubed. Okay, we bring x to the bottom and then plus with c. For question D. So we have integration of 3x minus 2 all to the power of 7 respect to x. Now, we have the power of 7. We cannot expand, right? So what we need to do is to apply the general power rule. But we have to make sure that everything inside the bracket is in the form of ax plus b. So, applying the general power form, the basic rule, what do we get? This ax plus b will be copied back. So, we have ax plus b here is 3x minus 2. And then the power will change into by plus 1. So, 7 plus 1 is 8. And divide by the 8 itself, and then the coefficient of x, which is a. So, what is the coefficient of x? Here is 3. So, we have to divide by 3 also. So, the denominator will be 24. So, 3x minus 2 all to the power of 8 divided by 24 plus c. Okay. For question E. So, we have integral of 1 over 5x plus 4 all to the power of 4 respect to x. So we don't have any formula for this one, but we can apply the rule of indices, which is this will be 5x plus 4 all to the power of negative 4. Rule of indices. Okay, so apply the same formula here because it's a linear inside the bracket. So it will be 5x plus 4th power of negative 4 plus 1, which is negative 3, and also divide by negative 3, and also multiply by the coefficient of x, which is equal to 5, and then plus with c. So the answer is 1 over negative 1 over 15 of 5x plus 4th power of 3. Okay, because we bring down again the negative 3 to the bottom, to the denominator, so we also need to add up by c. Okay, simple, right? Simple. You have to try it, and then you will see how simple it is for the integration. Okay. Okay, so let's continue with the next part of this lecture, which is integration of exponential function. Okay, so exponential function, we either have a simple power of exponential, or we have a function at the top as a index. Okay, so for function in exponential form, the following formulae can be used to determine the antiderivative. Okay, the first one is the integration of e to the power of x. So here we only have a simple power of x. So the integration here will be the original function, which is e to the power of x plus c. Also, if we have the power of ax plus b, which is a linear, then the answer will be e to the power of ax plus b, which is the original function. The same as differentiation, but now we need to divide with the coefficient of x here. So 1 over a. So this is only applicable for the function with the power of a linear, ax plus b. Okay, so this a cannot be 0. If we have 0, then we don't have any x, right? So it's just a e to the power of b. So e to the power of b is just a constant. So integrate a constant, we use the formula of integrate a constant. Okay? Okay. So let's continue with example. So find the following integral. So a, we have e to the power of 5x respect to x. Then what we need to do, we just copy back everything in the question. So it will be e to the power of 5x, and then you have to divide with the coefficient of x, which is 5. Okay, so the answer will be e to the power of 5x divided by 5 plus c. We also can take out it as a coefficient 1 over 5. The same thing lah, both are the same thing. Okay, so for question B. So, if you want to find the integration of 2 of e to the power of 3 minus 5x respect to x, then this 2 is just a coefficient. We can take it out as a coefficient, and then we just need to solve for e to the power of 3 minus 5x. So what we need to do, we just copy back everything in the question, and then we need to divide with the coefficient of x. So the coefficient of x here is negative 5. So divide by negative 5. So simplify the answer, we will get negative 2 over 5 multiplied by e to the power of 3 minus 5x plus c. Okay? Okay, so what if we have the integral of the form f prime x of e to the power of fx respect to x? Okay, for this type of function, we have the e already, which is to the power of fx, but now we have a coefficient of f prime x in front of the e. Okay, what we need to do, because this fx is the power of e, if we remember about the differentiation, we differentiate e to the power of fx, right? So what is the formula? We will get e to the power of fx, and then we need to multiply by f to the power f prime x, the derivative of the index. Okay, so this is actually the antiderivative of the e to the power of fx. Okay, so we just have to apply the formula lah. So if we have in the question, we have already the f prime x e to the power of fx, then the integration will be e to the power of fx and plus c. Okay, why? Because this fx might be not linear, because we have only the function for linear. It might be quadratic, or it might be surd, it can be anything. So if we have the derivative of the fx in front of the exponent, then we are okay by using this formula. Okay, for example number 6, so question A. So now we want to integrate to x e to the power of x squared respect to x, right? So e to the power of x squared, if we have the derivative of the x squared in front of the exponent, then directly it's actually e to the power of x squared. So the fx here is equal to x squared. So suppose the f prime x should be equal to 2x. If it's exactly like this, then we can just directly give the answer equal to e to the power of fx, which is equal to e to the power of x squared plus c. Okay, so this is for question A. Okay, usually I will ask my student to write down what is the fx, and then do we get the same f prime x as in the question. So let's see question B. So we have a function of integration x squared e to the power of x cubed. So let's say this is our fx, right? The index of the exponent fx is equal to x cubed. Suppose the f prime x should be equal to 3x squared. But now we only have x squared. Okay, so we only have x squared. Supposed to be 3x squared. But in the question we don't have 3. So we have to eliminate the 3 so that it will be the same as the question. So how to eliminate 3? We need to multiply by 1 over 3. So that's why it's 1 over 3 of the integral. Okay, so this is actually 1 over 3. So the integral of 3x squared e to the power of x cubed respect to x is e to the power of x cubed. So this part we directly get e to the power of x cubed. But now we just have to multiply with 1 over 3 and then plus with c. Okay, so we have to modify so that we following the formula f prime x multiplied by e to the power of fx. Okay, so for question C, we have x multiplied by e to the power of x squared minus 2 respect to x. So what do you think about this type of question? Okay, we just directly integrate? No. Okay, usually we will be expanding this type of question. So expand x multiplied by e to the power of x squared and then x multiplied by negative 2x and then both x multiplied by negative 2. So we have negative 2x here. Okay, so for the first term, we have e to the power of x squared. So we can write down that fx is equal to x squared. Suppose our f prime x, if we want to use this formula, then it should be 2x. But now we only have x. So suppose it's 2x, right? So we have to eliminate the 2 so that it will be the same as the question. So how to eliminate the 2? We need to multiply by 1 over 2. Okay? So this question mark here should be multiplied by 1 over 2 lah. So the integral of 2x e to the power of x squared will be e to the power of x squared. So 1 over 2 of e to the power of x squared, and then integrate the 2x will be 2x squared over 2, which is equal to x squared. So the final answer is equal to now 1 over 2 e to the power of x squared minus x squared plus c. Okay. So special case of x power of n respect to x when n equal to negative 1. So we have the basic rule where n must not equal to negative 1, right? But what if n equal to negative 1? So it should be remembered that we differentiate natural log of x, we get 1 over x. So the antiderivative of 1 over x, the reversing of it will give you integrate of 1 over x respect to x equal to natural log of x plus c. But remember that we need to put the absolute notation here. Why? Because log must always a positive number. Okay, we cannot have a negative number inside log function. Okay, so you have to remember this formula lah. This is a special case of x power of n. So example, find the following integral. So we have integrate of 1 over 3x respect to x. So this 1 over 3 can be factorized out as the coefficient, right? So we just need to integrate 1 over x. So integrate 1 over x, we get natural log of x. So the answer will be 1 over 3 natural log of x plus c. So don't forget to put the absolute. Okay. So for question B, integrate of 1 minus 5 over x respect to x. So we can integrate separately. So this is product addition rule. Sorry. So we can separate as integrate of 1 respect to x minus 5 of integrate 1 over x respect to x. This 5 is just multiplication as the coefficient. So we can take out it from the integration. notation. So integrate 1, we get x. Integrate 5 multiplied by 1 over x will be 5 natural log of x plus c. Okay, don't forget to put the absolute x. So, you have learned that derivative of natural log of 1 plus 3x is equal to 3 over 1 plus 3x. So, what is 3? This is the fx. 3 is actually the f prime x, right? So, the integral of 3 over 1 plus 3x will get you natural log of 1, absolute 1 plus 3x plus c. Right, so in general, the differentiation of natural log of fx equal to f prime x over fx. So, the integral of f prime x over fx respect to x will give you natural log of absolute fx plus c. Okay, just the reverse process of the differentiation. So, we can apply the special formula, reversing using the antiderivative lah. Okay, now let's see some example on this type of formula. So we have 4x over 2x squared plus 1 respect to x. So our fx always in the denominator. So check first. Our fx equal to 2x squared plus 1. So f prime x should get 4x. So do we have the same form? Yes, this 4x is exactly f prime x from the fx. So, we can directly write down the answer as natural log of absolute 2x squared plus 1 plus c. So, absolute of the natural log of absolute of the fx. Okay. So, for question B, if we have absolute integral of 2x minus 1 divided by 3x squared minus 3x minus 1 respect to x. First of all, what is our fx? Our fx is 3x squared minus 3x minus 1. So, f prime x should be equal to 6x minus 3. Do we have the same form of f prime x inside the question? The numerator is not the same, but we can write down it as 3 factorize out, we have 2x minus 1. So, we should have, basically we should have 3 of 2x minus 1. Right? So it should be a 3 of 2x minus 1. But we don't have 3 here. So how to eliminate 3? So we need to multiply by 1 over 3. So here we need to multiply by 1 over 3 so that these 3 can cancel out. So we have the original question back. Okay? So what we need to do? We need to multiply by 1 over 3 and then just put natural log of fx. So natural log of absolute fx, which is natural log of absolute 3x squared minus 3x minus 1, and then plus with c. Okay, so you understand how to modify. This is the same as when you trying to find what is it really true, f prime x of e to the power of fx. This f prime x, is it this the exact answer for the fx? If not, then you have to modify, just like this one. Okay, next question, C. We have 6x squared minus 8x plus 6 all over x cubed minus 2x squared plus 3x, and then we integral respect to x. So, what is our fx? Write down our fx. Fx is equal to x cubed minus 2x squared plus 3x. So, f prime x, the numerator should be in the form of 3x squared minus 4x plus 3. But what do we have here? We have 6x squared minus 8x plus 6. So how do we modify this? Okay, so suppose 3x squared minus 4x plus 3, but we have here is 6x squared. So to get 6x squared, these 3 should be multiplied by 2. So we need to put 2 in outside the formula, outside of the integral. So if we multiply by 2, so 2 multiplied by 3 is 6, 2 multiplied by 4 is 8, 2 multiplied by 3 is 6. So we get the same thing as in the question. So we need to multiply by 2 of the natural log of absolute x cubed minus 2x squared plus 3x plus c. Okay. If we get directly, the question is 3x squared minus 4x plus 3 all over x cubed minus 2x squared plus 3x, then it's directly this answer, natural log. But because the question give you is the multiple of 3x squared minus 4x plus 3. So we need to find what is the multiple of. Okay? Okay, so let's continue. Integrate in the form of integrate f prime x multiplied by fx all to the power of n respect to x, then the answer will be the f of x to the power of n plus 1 and then divided by n plus 1. Okay, so this is actually come from the general power rule in differentiation. So we know that differentiate f of x to the power of n, it will be equal to n of fx to the power of n minus 1 and then multiply by f prime x. Okay, so this is f of x power of n. But if we follow this type of question, this plus 1, right? So it will be plus 1 minus 1. Here also will be n plus 1 minus 1. Okay, this n plus 1 minus 1 will be here. Right? So we need to bring it. Ini tak payah. This one, n plus 1 only, right? So we bring the power to the front, n plus 1 lah. So if we bring n plus 1 here, it will be the same thing as here. Right? It's just f of x power of n plus 1 minus 1, which is n only, multiplied by f prime x. So it's the modification from the general power rule in the differentiation. Okay? Okay, so let's do some example on this type of formula. So integrate a 3x squared multiplied by x cubed plus 6 to the power of 4. So if it's to the power of 2, then you can just directly expand. But now we have the power of 4, it will be hard for you to expand this type of expression, right? So we can just use the general power rule formula. Okay, so first of all, we need to check what is our fx. So our fx will be in the bracket lah. So our fx should be x cubed plus 6. So f prime x, the multiplication f prime x should be equal to 3x squared. So do we have the same value for f prime x? Yes, it's exactly. So you can directly apply this formula. So the answer should be, yes, copy back the fx, which is equal to x cubed plus 6, and then the power will be adding up by 1. So 4 plus 1, which is equal to 5, and then also divide by 5, and then plus with c. Okay, so check first whether the f prime x is the same, exactly the same if we differentiate the fx. So for question B, 3x squared divided by 2x cubed plus 4 all to the power of 6. So this is the same thing as the earlier part. We can bring the 6 as the power in the numerator. So it's actually equal to 3x squared multiplied by 2x cubed plus 4 all to the power of negative 6 respect to x. So what is our fx? The fx is 2x cubed plus 4, right? So the derivative f prime x should be equal to 6x squared. But what we have here is 3. Right, so we write down it should be 6x squared multiplied by 2x cubed plus 4 power of negative 6. So this should be in the form, it should be in this form lah. This one, the derivative should be 6x squared. But what we have is only 3x squared. So how to get 3 from this 6? So we need to do something to this 6. So we need to divide by 2 or multiply by 1 over 2. So that's why we need to multiply by 1 over 2 in front of the formula. So it is true, but we need to multiply by 1 over 2. So use this formula fx, which is equal to 2x cubed plus 4 to the power of n plus 1. So negative 6 plus 1 is negative 5. And then also divide by negative 5. So the final answer will be negative 1 over 10 of 2x cubed plus 4 all to the power of 5. Negative 5 will be to the power of 5 in the denominator. Okay. So next question, question C. Wow. So we have the integration of 1 over 2x plus 3 multiplied by x squared plus 12x all to the power of 5. Okay, now we have this fx here, which is x squared plus 12x. So f prime x should be in the form of 2x plus 12. Okay, so we write down at the bottom 2x plus 12 multiplied by x squared plus 12x to the power of 5. But what we have is 1 over 2 or 3 here, the value. So how to get 3 from this 12? We need to divide this 12 with 4 or multiply by 1 over 4. So that's why we need to divide by 1 over 4. Okay, so 1 over 4 of, use the formula lah, fx is equal to x squared plus 12x all to the power of n plus 1. So 5 plus 1 is equal to 6 over 6. And then plus c. So simplify, 4 multiplied by 6 is equal to 24. So x squared plus 12x power of 6 divided by 24 plus c. Okay, conclusion. So this is the conclusion of the lecture 1. So what we have learned in this lecture, actually we have learned 9 basic rules of integration. The most basic one, when you integrate a constant. So a constant of 1 will be x lah. So if it's a constant of k respect to x, that will be k of x plus c. And then integration of k of fx, then this k is just a coefficient of fx. So we can take out it and then just integrate the fx. And then the second one is integration of x power of n respect to x. So the power will be adding up by 1 and then you need to divide by n plus 1 and then plus c. So plus c is common for every time you integrate. And then if we have a linear to power of n, then we can just use the general power rule also. So it will be the linear ax plus b to the power of n plus 1 also, and then divide also with n plus 1. But you need to divide with the coefficient of x, the derivative of ax plus b actually, and then plus c. And then 5, we have e to the power of ax plus b. You just copy back everything, the question, and then divide with the coefficient of x, or the derivative of ax plus b. Number 6, integration of f prime x over fx respect to x is directly equal to natural log of absolute fx plus c. So this comes from the differentiation formula. And then integration of 1 over x respect to x directly equal to natural log of absolute x plus c. And number 8 is integration of f prime x multiplied by e to the power of fx, then directly it's equal to e to the power of fx itself plus c. And lastly, if general power, from the general power rule in differentiation, integration of f prime x multiplied by fx power of n, then it will be fx power of n plus 1 divided by n plus 1 plus c. Okay, so this fx can be anything lah. It's not only linear. So please do your own notes so that you can just you can directly read your notes when you do the tutorial question. So that's all for lecture 1. Thank you class. Please do tutorial 1 of lecture of topic 2.